इसका कैमरा जूम इन जूम आउट किया क्या किसी ने? कैमरा सही साइड में नहीं है। एक मिनट म्यूट। Yes. Good afternoon to everyone. Just do reply. Am I audible? In today's class, we are going to continue discrete time signals and system. Very good afternoon to all of you. Welcome to you all on the IMS GATE Academy platform. Just do reply, bachcho. Shall we go for? Shall we start today's session? All of you just confirm audio and video is crystal clear. You are able to listen correctly. My voice is coming to you properly, guys. Yes. Chali. So let's start the today's class. First question. I think ESE 2017 2 marks question we have already solved in the last class. Yes or no? Suraj, Purushottam, do reply, beta. My voice is clear. Yes. Chali. So I think this was the last question of last session. We have discussed this, a 2 marks question, ESE 2017. Now today's class I am going to start with this question. It is again a 2 marks question asked in EE 2017. The output YT, examiner is asking for the output YT. Clear, sir. Very good, beta. Suraj, Tushar, Shabash. So the output YT of the following system is said to be sampled. Let me change the color of pen. First of all, yellow here. Here I am taking white. Here is also this. Okay. So you should check the student the output YT of the following samples so as to reconstruct it from its samples uniquely. The required minimum sampling rate is. The required minimum sampling rate is what? For the output YT. Not asking for XT, guys. Yes. So first of all, you have to identify ki what is the input signal. So at this point, whatever the signal is coming, that will actually work as a input. Yes or no, Tushar, Suraj, Purushottam? So it means if I will take this signal as a Z of t, then this my ZT is actually equal to what? XT is coming from this side. XT and this is multiplier, so multiple of cos of 1000 pi t. So this is your actual input, guys. This is your actual input, and here h of t is given to you. And if you have attended my signals and system classes from the first class, or if you already attended the Fourier transform lecture, then I hope you know what is the Fourier transform of this. How many of you guys can directly identify sine of 80 upon pi t? Sine of 80 upon pi t directly gives you a low pass filter, directly gives you a rectangular pulse in the frequency domain. So don't you think, sir, if ht value is, we all know that ht is nothing but sine of 80 upon pi t will give us a low pass filter, will give us a rectangular pulse in the frequency domain. So here is sine of 80 upon pi t minus a2 plus a in omega 1. So this is the general Fourier transform. But here in this question, the ht value is actually sine of 1500 pi t, 1500 pi t upon pi t, sine of 1500 pi t upon pi t, sine of 1500 pi t upon pi t. So you should tell me guys ki what is sine of 80 upon pi t. It means you should tell me here what is sine of a, 1500 pi. So you should write 1500 pi 2 plus 1500 pi, 2 plus 1500 pi omega, and this is what 1. So this is nothing but sine of 80 upon pi t, again sine of 80 upon pi t, like this. Yeah. I hope it is clear guys, yes or no? So it means for sure this h omega is working as a low pass filter which will only allow the frequency 1500 pi in omega, and if I wish to find in hertz, then I need to divide with 2 pi, so it will be 750 hertz. Is this clear? Now what is your object now? Ki sir, we are looking for the sampled version or Nyquist rate for the YT. But first of all, I need to reach to YT from ZT. So input is ZT, H omega will work as a low pass filter. Now my object is I need to check ki what is the maximum frequency of the input signal ZT. Come on guys, come on, tell me. What is the maximum frequency? So don't you think if xt has a maximum frequency omega m, and this frequency is nothing but, let me take omega c, then because these two signals are actually multiplied, in the time domain, so it will be convolved in the frequency domain. So if xt has a maximum frequency, let me take omega m and let me take here the maximum frequency omega c, then the ZT has the maximum frequency is nothing but omega m plus omega c. And do you know what is xt omega m? This is xt x omega given 1000 pi. So that is why I am writing here 1000 pi plus omega c value is also 1000 pi. So it is nothing but 2000 pi. 2000 pi radian per second. This is the maximum frequency of input guys. This is the maximum frequency component of input signal. Input matlab z of t. So now I got the maximum frequency component, that is 2000 pi radian per second from the z of t. It means whatever the z omega will be there, the maximum frequency content 2000 pi. The maximum frequency content 2000 pi. Bolo हाँ या ना बच्चों, yes or no? But don't you think this is the smartest approach to solve the question? However, here z omega diagram is not required. If you are making the diagram, you are wasting your time. Now, what should be the ideal approach to solve this question? Once the question is coming in the GATE exam, first step student can directly identify, okay, ht is given to sine of 80 upon pi t. It insists you to make the low pass filter. So you already made the low pass filter. It means now you know the cutoff frequency of low pass filter is 15,000 pi. 15,000 pi. Okay. Now here your next object is what? You have to find the maximum frequency component of input signal. Now you already got 2000 pi. Now tell me student, from the input side, the maximum frequency component is coming 2000 pi radian per second, but in the low pass filter, it will only allow 1500 pi. Krishna, good afternoon beta. So from the input side, the maximum frequency in radian per second is 2000 pi radian per second, but in the low pass filter, 15,000 pi is the cutoff frequency, sir. 1500 pi is the cutoff frequency. It means at the output, the maximum frequency that will be available will be only 1500 pi. Very good afternoon, Krishna. All of you guys do reply. Suraj, Tushar, you are getting this or not? Now tell me what is the maximum frequency? What is the maximum frequency at output YT? At output YT, what is the maximum frequency? It will be only 1500 pi. It will be only 1500 pi. It means we can say that the output maximum frequency will be 1500 pi in radian per second. So if I will divide with 2 pi, it will be 750 hertz. So Nyquist rate of output YT is nothing but twice of FM. Twice of FM means twice of 750. So answer is 1500 hertz. 1500 hertz or 1500 samples per second. So answer is nothing but B for Bombay only. I hope this part is clear to you. 1500 samples per second or, very good bachcho, very good, shabash. 1500 samples per second or 1500 hertz is the correct answer. So this is the smartest approach. If I will go for the lengthy approach, conventional approach, then student, in the conventionally you can also think like this. Conventionally for this question, how can you solve? So if I talk about conventionally now, what is my z of t? My z of t is nothing but sir x of t into cos of, I just multiply this, x of t into cos of 1000 pi t. However, I already got the answer. I am just giving you an idea how conventionally you can solve the same question. Yeah. And do you know examiner has already given x omega? This is x omega is already given to you. This x omega diagram is already given to you. And do you know x omega diagram, maximum frequency, minimum frequency is given. So 1000 pi omega. So this diagram is given in the given in the question itself. It means xt, maximum frequency 1000 pi is given to you. Now here it is says that 1000 pi t again. Yes or no guys? Yes. So if I solve conventionally, then I am taking the Fourier transform. So if I will take its Fourier transform, what I will get? I will get the Fourier transform z omega as a x omega. Multiplication in time is nothing but 1 upon 2 pi convolution in frequency. Tell me guys, yes or no? Multiplication in time is nothing but 1 upon 2 pi convolution in frequency. It means x omega convolution with cos. What is the Fourier transform of cos? Do you know? Remember guys, pi already outside, sir. Now inside the bracket you can write del of omega plus omega 0, it means 1000 pi, and again plus the del of omega minus 1000 pi. How many of you guys getting this? I hope you remember this. So this is nothing but the Fourier transform of cos 1000 pi t. Omega 0 value is 1000 pi. Now student, when you will convolve, this pi get cancel out actually. So ultimately it will be 1 upon 2, and convolution with shifted impulse. Convolution with shifted impulse, because here is omega. So that is why complete this term will be replaced with omega. So it will be actually x of omega plus 1000 pi, and plus again you will just transfer this term also here omega. So it will be actually x of omega minus 1000 pi. I hope this part is clear to you. So this is nothing but your z of omega, and ultimately if I wish to draw this, if I wish to finally draw this, ultimately the maximum frequency what will come? Suraj, Krishna, Tushar, the maximum frequency should be 2000 pi only, because in the previous slide we got 2000 and we already got the answer, option number B. Right now we are just discussing the conventional approach, which is not at all actually required in the GATE exam, but just for your better understanding I am making this. So tell me, what is x omega minus x omega minus 1000 pi, x omega plus 1000 pi? It means this x omega one time will shift in the right hand side by 1000 pi distance, and one time will shift in the minus 1000 pi in the left hand side, and finally we have to add. So it means after adding I will get a curve like this. After adding I will get a curve like this here. So don't you think now here is 1000 pi actually, and because this is shifted by 1000 pi in the left hand side, so the new will be what guys? The new diagram will be nothing but 2000 pi, and here it will be minus 1000 pi, and here it will be minus 2000 pi, and whatever the magnitude, now magnitude has been amplitude scale by half magnitude. Yes. So this is nothing but your z omega. This is nothing but your z omega. And do you know what is h omega? Sir, h omega we know that low pass filter, sir. This is your h omega guys. I am making a small diagram. So h omega having the maximum frequency 1500 pi minus, or here is plus 1500 pi. This is an omega magnitude 1. This is a low pass filter. It is a low pass filter, LPF, low pass filter. So now finally what you will get? This is z omega. So now finally what you will get guys, do reply. Finally what you will get? Because it will only allow y omega. So y omega is nothing but x omega dot h omega. Y omega is nothing but x omega, z omega dot h omega, z omega dot h omega. So 15,000 pi, after that it will not allow. So the new diagram of y omega will be look like this, from here to here, here to as it is, and after that like this. Similarly from here to here as it is, like this, and after that as it is. So here what you will get minus 1000 pi, you will get minus ka 1500 pi, you will get here plus ka 1000 pi, and you will get here plus ka 1500 pi omega. Yeah. So now you should tell me what is the maximum frequency of y omega? 1500 pi, and in FM, so in frequency, the maximum frequency of y omega is nothing but 750. So the Nyquist rate, minimum sampling rate, is nothing but twice into 750. So answer is still 1500 hertz or samples per second. So whatever we have discussed here, it is nothing but method number 2, and it is actually a conventional approach, which is not at all required for the solution. Solution we have the question we have already solved in the last slide only. Bolo bachcho, shall we go for next or wait? All of you guys will reply fast. Everyone do reply fast bachcho. Shall we go for next or wait? Shall we go for next or wait? Come on. Yes. Each and every student just do reply fast. Shall we go for next bachcho? Next sir. Chaliye. Shabash. Shabash Krishna. Krishna, very nice. Chaliye. So now student, next question is here. This question I am expecting from you. This is a question asked in EC 21, GATE Electronics and Communication 21 question. Consider a real valued baseband signal, band limited to 10 kilohertz. It means FM is given to you guys. The FM is given to you for this signal, that is 10 kilohertz. The Nyquist rate of the signal XT, it means XT maximum frequency is given to you. And asking for the Nyquist rate of YT, YT is nothing but XT multiple of X of 1 plus T by 2. This question I am expecting from you all guys. Take your time and try to complete it, beta. All of you guys take your time and try to complete it. I am waiting. I am waiting for your response. Just try to complete it. Take your time. Correct. Here also multiple concept. In the last question, just before 2 minutes we have solved the last question also. In the last question also we have the same concept. Multiplication in time is nothing but convolution in frequency. So Krishna got the answer option number C. Let me check other students. Other students should also reply. Tushar, Suraj, Purushottam. क्या बात है, very good attempt beta, very good attempt. चलिए. So first of all student, how many of you remember that if xt is having this, then what about x of 80? So we know that sir x of 80 maximum frequency now will be multiple with the scaling factor. Whatever it is AFM. So it means if I talk about x of 1 plus t by 2, so time shifting does not affect maximum frequency. Time shifting does not affect, but time scaling affect. And here a value is half, so I am writing here half of FM. So this will be the Nyquist, this will be the maximum frequency of x of 80. So if I talk about the maximum frequency of xt, then I will get what? FM, that is nothing but 10 kilohertz. And here convolution in time is nothing but multiplication in time is nothing but convolution in frequency. So the frequency we should convolve FM plus here t by 2. It means here FM by 2. Because scaling factor is half now, so half into FM. So now this is the maximum frequency of YT guys. Now this will be the maximum frequency of YT. And what we are looking for? We are looking for the Nyquist rate. So Nyquist rate of YT, Nyquist rate of YT is nothing but twice into FM plus FM by 2. Now you can just let me know कि twice into what is FM. Why we have added? Because convolution in time is multiplication in time is nothing but convolution in frequency, and in the convolution we are always adding the maximum limit and minimum limit. So what is the FM value? FM value is still 10 kilohertz, sir. So it is again 10 upon 2. So 10 plus 10 by 2 it means 5. So 10 plus 5 15. 15 2 ja guys 30. So it will be actually 30 kilohertz. So answer is nothing but C for Chennai Super King. Correct answer is CSK guys. Do reply fast. Hi Anna. Everyone do reply fast. Is this clear beta? Each and everyone do reply fast. Is this crystal clear? Chale. All of you let me know, N or W guys. Shall we go for next? Shall we go for next? Yes or wait? Chali. So I think 30 kilohertz, this question is clear to you and you guys already corrected. Yes, shabash. Again a very good question is coming, 2018 2 marks question. A band limited low pass signal XT has 5 kilohertz is sampled at a sampling rate Fs. Okay. Band limited low pass signal bandwidth. Student, if I talk about the low pass signal, for the low pass signal bandwidth is nothing but FM. So it means the maximum frequency FM is given to you. It is 5 kilohertz. I am giving you a hint. After that, student, the signal XT is reconstructed using the reconstruction filter HF, whose magnitude response shown figure. The minimum sampling rate in kilohertz for the perfect reconstruction of XT. I am expecting this question from you guys. Try to solve it. I am giving you 1 minute time. I am giving you 1 minute time for this. 1 minute is sufficient to solve this question, guys. Take your time and try to solve this. What is this happening, guys? Yes. So now time started, guys. Time started. All of you try to complete this. Try to solve this question. It is a numerically entry question, guys. Suraj, all of you do reply, bacho. Try to complete this question first. Yes. Do reply, bacho. Anyone who is with final answer, do reply. Suraj, Tushar, Krishna. Chali. So if you are not able to solve, now I am solving this question here, guys. At least you should give your attempt, beta. Chali, no problem. Now student, you should just listen carefully. Here we have the maximum frequency FC, but why this question is important? Because generally what student will do, student just directly take the NICU's rate just by twice FM. So if they will go for twice FM now, they will get the answer twice into 5, 10 kilohertz. So they will type here 10 kilohertz, and 10 kilohertz is not at all correct answer. Now Krishna says that 11 kilohertz. Why, sir? Because Krishna taking the cutoff frequency of low pass filter is 6 kilohertz. Yes. So if you will take 6, Ayush, first you should solve this question, beta. So if you will take 6 na, then by using this formula, I told you to find the Nyquist rate. We are having this formula, but this is not only sufficient. We should also check this. FC is nothing but Fs minus Fm. If cutoff frequency of low pass filter is given, then this formula we should also check to find the minimum sampling frequency. So here in this case, cutoff frequency is not 6 actually. If you will take the cutoff frequency 6, then 6 plus 5 you will get 11 kilohertz, and again you will be wrong. Student, it is a trapezoidal nature, and of course low pass filter can be like this also. So cutoff frequency of low pass filter is 8 kilohertz here. So I am writing here 8. Fs will give me minimum sampling rate, and Fm is nothing but 5. So Fs is nothing but 8 plus 5, 13 kilohertz for this question. Because kilohertz is already given, you have to numerical entry type question. So you have to type the number 13. You have to type number 13 to get the correct answer. Yes. Is this clear, beta? Krishna, Suraj, I am very happy that Krishna at least has attempted. Ayush Kumar, do reply, beta. Shall we go for next? Everyone, guys, do reply fast. Shall we go for next? Yes or wait? Yes or wait? Chali. So correct answer for this question is 13 kilohertz. 13 kilohertz. Come on. So very soon we will discuss the discrete time also, discrete time signals also. We will discuss first discrete time signals, functional representation. After that, operation of signals we will start. Okay. Chali. So here is the next question, guys. Just based on the sampling theorem, the Fourier transform of xt and yt, that is x omega, y omega, is given to you. Find out the Nyquist sampling rate of xt and yt in kilohertz. In kilohertz. Do it fast. Krishna, I am Vedai, sir, but my name is Krishna also. Okay. Okay, Krishna. Yes. Shabash, Vedai, beta, Vedai. Yes. So Krishna, Vedai, is it your like घर का नाम है आपका Krishna? Yeah, this is your other ID. Okay, no problem. No problem, Vedai. Chali. Do reply fast, all of you. Ayush, Tushar, Purushottam, Suraj, do it fast. I think Vedai, this question is easy now because in the time domain we are having multiple. Yes or no, guys? Yes. So we are thinking that today Vedai is not attending the live class, but now Vedai is already attending by using the name Krishna. Okay, no problem. Do reply, pyare bachcho, do reply. Shall we go for next? xt.yt. Again, convolution, multiplication in time is nothing but convolution in frequency, and convolution. Sir, मेरे तो बहुत सारे ना. Okay, बच्चों. Okay, very good. चलिए, xt, yt, do it fast. Do it fast, Vedahi. Do it fast, Suraj, Ayush, Tushar. Easy question. Similar type of question, guys. So that is why I am expecting from you. This is a similar type of question. That is why I am expecting from you. Yes. Yes, everyone do reply. चलिए. So student, we can say that कि sir x omega and y omega maximum frequency is given to us in the frequency domain because we have to perform convolution, so we have to add the upper limit. So it means whatever the xt and yt maximum frequency will be, maximum frequency is nothing but 2 pi into 10 की power 4 plus 3 pi into 10 की power 4. So ultimately it will be actually 5 pi into 10 की power 4. This is my maximum frequency in omega, bachcho. This is my maximum frequency in omega. So if I will divide with 2 pi, here, what I will get, guys? Don't you think I will get here 50 into 10 की power 3 into pi upon 2 pi. So pi get cancelled and 2 say this is cancelled with 25. बोलो हाँ या ना? So it is 25 into 10 की power 3. It means it is 25 kilohertz. And 25 kilohertz is my maximum frequency. 25 kilohertz is nothing but my maximum frequency, and I am looking for the Nyquist rate. So what is the Nyquist rate? Nyquist rate is nothing but twice into FM. So Nyquist rate is nothing but twice into 25 kilohertz. So your final answer is nothing but 50 kilohertz. Bolo हाँ ना? 50. 50 kilohertz. It means you are supposed to type here 5050 only. You are supposed to type here 5050 only. हाँ या ना? Is this crystal clear, बच्चों? 25, whether he 25 is maximum frequency, but you are looking for Nyquist rate, better Nyquist rate twice FM. Is this clear? So answer is 50 kilohertz. Yes, Suraj? Chali. Again, बच्चों, next try to solve this one. Consider a signal with the amplitude spectrum this. So maximum frequency of omega is given to you. It means I am writing here omega m is given to you as a 1 radian per second. Okay. The Nyquist rate also asking in which radian per second only, not in hertz right now. For this signal GT equal to xt dot this. So tell me guys, if xt has a maximum frequency FM and cos 2t has a maximum frequency, not FM, omega m, and here the maximum frequency omega c, but because two signals are multiplied in the time domain, yes, Vedai, correct. चलिए, so Purushottam, tell me beta, omega m plus omega c. So don't you think the maximum frequency multiplication in time is nothing but convolution? It means the maximum frequency in the convolution we are adding, so the maximum frequency of gt, the maximum frequency of gt is nothing but omega m plus omega c. The maximum frequency of gt, is nothing but omega m plus omega c. बोलो हाँ या ना बच्चों? Yes. Omega m plus omega c. So asking for this Nyquist rate. So Nyquist rate is nothing but actually twice into omega m plus omega c. So now you should check twice into what is omega m. So omega m value is 1 and omega c value is 2. So answer is nothing but 2 plus 1 3 into 2 6 radian per second. Asking in radian per second only. So this time you have to type 6 only here. So this time you have to type only 6 here. बोलो हाँ या ना? Is this clear beta? Shabash, Vedai, shabash. Everyone do reply now. Shall we go for next, बच्चों? चलिए. So now we are going for the next students here. The discrete time signals we are starting. So if I talk about the functional representation, if I talk about the representation of discrete time signals, then we can represent the discrete time signals by using different techniques. So this is how we can represent discrete time signal. So if I talk about the first representation, I am writing functional representation. Functional discrete time representation, discrete time signals representation. So it means I can represent the signal just like this. Ki signal is x of n, taking the value n equal to 0, 1, n equal to minus 1, it is also 1, n equal to 2 and 3, it will be minus 1, and otherwise n equal to otherwise, or you can directly say that or else. Otherwise it will be 0. It means this is nothing but the discrete time signal but represented in the function form just like that. The same signal I can also represent by using graphical way. So graphical representation. graphical discrete time signals representation. So how graphically we can represent the same signal? If I want to represent the same signal x of n graphically, then at n equal to 0, at n equal to minus 1, at n equal to 1 here, n equal to 2 here, 3 here. So n equal to 0 or minus 1 pe 1, 1. So here we should write 1. We should write here 1, 1. Here also we are having 1 magnitude of impulse. And 2 and 3 pe minus 1. So what we can say that 2 or 3 minus 1, it means here also minus 1, minus 1. Even you can change this value also, you can take it 2 also at n equal to minus 1. So it is 2, then it is what? Minus 1. So like that it is. Like that it is. It is only 1, it is only 1, it is 2. It is minus 1, it is minus 1, yes. So this is my graphical representation of the same. It is very easy, guys, yes or no? Now the next is, if I talk about the third one is the best representation. Why best? Because it will take very less time. So we are writing the third representation as a functional, graphical, now sequential representation. Sequential representation of DT signals. Why I like this, bacho, and why I prefer this? Because if you will do and if you will write always sequential form, it allows you to take a very less time to solve the question. And even as far as operations are concerned, time shifting, time scaling, everything, generally students prefer graphical approach, but graphical is a lengthy approach. If you want to perform smartly all the operation, you should go for the sequence representation. Like that, if I wish to represent the same signal x of n, here from the curve, if I will check, then I should write here 2, 1, 0, minus 1, bracket close, and whatever is origin, I need to represent as an arrow mark. So you can say that, sir, arrow mark representing 0. So of course it is minus 1 only. So of course its value is nothing but plus 1 only. This value is nothing but 2 only, and this value is nothing but 3. So 2, 1, 0, 2, 3. I hope this is clear to you guys. I hope this is crystal clear to you. Everyone, guys, do reply fast. Is this clear to you, bacho? Shall we go for next? Now, student, if I talk about the fourth one is nothing but tabular representation. Tabular discrete time signals representation. The maximum we will prefer this sequential, so I am making a star mark here. Tabular form also examiner can give you like this. Tabular form also examiner can give. So here they will represent n and here represent x of n. The values are minus 2, minus 1, 0, 1, 2, 3 and so on. So now you can take the same example x of n value. X of n 0 pe 1, minus 1 pe 2. So minus 1 pe 2, here is 0, 0 pe 1, here is 0 and 2, 3, minus 1 like this. And rest all values 0, 0, so all are 0. So this is nothing but your tabular form representation, n or x of n, yes, n or x of n. Just complete, bachcho, all the 4 representation, just complete it. Just complete, pyare bachcho, all the 4 representation you need to complete. After that, we will start the operation on signals. However, you all are comfortable and habitual to the operations, as we already discussed time shifting, time reversal, time scaling, all the operations, all the transformation of signals we have already discussed in chapter number 1 as far as continuous time signals and system concerned. However, here we are going to discuss the discrete time operation, but the concept remains same. Only changes is what, guys? There we have it xt with respect to time, and here we have a xn with respect to n, and n is discretized in time domain. That is the only, so that is why we are having different samples at the particular instant of time. Chaliye, so now let me start. Hello Suraj, sir, पहचान छुपाकर क्लास अटेंड करने के जुर्म में आर्टिकल 18 के तहत इन्हें चलो भाई, वेरी गुड। चलिए पुरुषोत्तम, इतना बड़ा टाइप कर दिया आपने। नो प्रॉब्लम। कड़ी उपाधि प्रदान की जाती है इन्हें कड़ी की उपाधि प्रदान की जाती है। अच्छा, क्या लिखा है? आई एम नॉट, अच्छा ठीक बा वेरी गुड वेरी गुड वेरी गुड, नो प्रॉब्लम बच्चों। कोई भी नाम हो, आप लोग अटेंड करते रहें लाइव में और एंजॉय करते रहें लेक्चर्स को, इसी तरह हंसते रहें, मुस्कुराते रहें, पढ़ते रहें। चलिए, सो बच्चों नेक्स्ट हम बात करते हैं ऑपरेशंस ऑन सिग्नल्स। यस, ऑपरेशंस ऑन डीटी सिग्नल्स, ऑपरेशंस ऑन डीटी सिग्नल्स, operations on discrete time signals, operations on discrete time signals. ये now all of you should check. If I talk about the first operation, guys, that is nothing but simple time reversal operation. Time reversal operation. If I talk about the first operation, that is time reversal, what should I do? Time reversal operation. So if I talk about, let me take the signal x of n as a, let me take the signal x of n curve is given to you 1 3 2 1, and here is the arrow. It means it is my sequential form. So in the graphically form, how to make the curve? So graphically I should make the curve just like this. This is 0 1 2 3. I am taking any example. So the first is 1, this is 3, 1 3 2 1, 1 3 2 1, just like this. This is what, guys? This is your n. This is your n and this is your x of n. So you can make the magnitude 1 3 2 1, and this is your x of n, guys. This is your x of n. So if I am asking this first question, if I am asking the first question here, the first question is x of n minus 3, and the second question is here, that is x of n plus 6. Yeah. So pure time shifting. So as far as time shifting is concerned, we all know that x of n minus n naught or x of n plus n naught. Two types of time shift is possible. X of n minus n naught, it means again RSS, right side shift, and n plus n naught, it means LSS, that indicate left side shift. By how much distance? By n naught distance, n naught distance. It means here, student, if I perform graphically, however, as I told you, I will teach you how to directly shift in the sequence itself, but first of all we will discuss the lengthy approach. After that we will discuss the short approach, shortcut method. Okay. So x of n minus 3, it means this is my x of n 0. I have to shift this signal in the right hand side by how much distance? By 3 distance. So if I will shift this signal, by 3 distance in the right hand side, then my 0 will become what, guys? So you will say the 0 will become 3. So you should write here 1 3 2 1, 1 3 2 1, and this value is nothing but 3 4 5 6. बोलो बच्चों, हाँ या ना? Is this clear to you, beta? हाँ या ना? X of n minus 3. So what you should write? You should write here 1 3 2 1. Yeah. So 0 will be 3 4 5 6. So this is nothing but x of n minus 3 diagram. If I am looking for x of n plus 6, if I am looking for x of n plus 6, yeah. N plus 6 means you have to shift this signal by 6 distance in the left hand side. So your 0 will become what, guys? Your 0 will become minus 6. So minus 6, of course, minus 5, minus 4 and minus 3. So it will be actually 1 3 2 1. So actually it is 1 3, actually it is 2 and 1. So you should write here 1 3 2 1, and it is nothing but what, guys? X of n plus 6 with respect to n. बोलो प्यारे बच्चों, हाँ या ना? Is this clear to you? Is this clear बच्चों, हाँ या ना? So x of n minus 3 or x of n plus 6, both is crystal clear. Graphically we have did graphically here. Yes. Now student, we will solve the same question by using the sequential shifting. So if you want to save your time and if you want to directly perform x of n minus 3, if you want to directly perform x of n minus 3 in the sequence itself, then what you need to do? Student, you have to treat this x of n as a, x of n minus ka 0, x of n minus ka 0. So that is why starting from 0, origin. So if I talk about x of n minus ka 3, acha, it means it is nothing but, sir, 1 3 2, 1, and instead of 0, this time it is starting from 3, so it is nothing but 3. So if it is 3, then 3, 4, 5, 6 as it is. So this is x of n minus 3. Now here you can save your time, guys. And this is the best approach to perform shifting as far as discrete time signal is concerned. We should always give preference to the sequence representation as far as operations are concerned in discrete time signals. हाँ या ना? हाँ, करी की उपाधि से क्या मतलब है सर? मुझे समझ नहीं आया. I also don't know kari means what. Anyway, no problem. It is just for the fun. Okay, no problem. चलिए हंसते रहे, मजाक करते रहे, हंसी मजाक करते रहे आप लोग सभी. चलिए प्यारे बच्चों, do reply fast. This x of n minus 3 is clear. Now what is x of n plus 6? What is x of n plus 6? So tell me here, as I told you already, you need to treat this part as a x of n minus, and this time is nothing but minus 6. It means 6, it means 3, 1, 3, 2, 1, 3, 2, 1. So this time your 1 should be equal to, this time your 1, this 0 is replaced with minus 6. So of course it is minus 5, it is minus 4, and it is minus 3. As it is only, as it is only. So this is how, guys, you can save your time. This is how, guys, you can save your time. Bolo aaya na? Shall we go for next? Shall we go for next? Purushottam, Vedahi, bolo bhai, bolo Krishna, Suraj. Do reply fast. Come on. So now I am expecting one question, one shifting question from you. Let me take x of n value as a 3, 2, 4, 1, 2, 5. Okay, and here I have an arrow. Okay, yes sir. Now can you please directly tell me what is x of n minus 5 now? Can you please directly tell me now x of n plus 6 or x of n plus 10? Can you directly tell me yes or no? Of course, sir, we can directly write without wasting of time. We can directly design this. X of n minus 5, it means the values remain same. So 3, 2, 4, 1, 2, 5 remain same. But the origin will replace with earlier origin 0. But this time the arrow mark is replaced with 5. So it is 5, 6, 7 like this. Similarly, what should I write here? I should write here 3, 2, 4, 1, 2, 5. And here student x of n plus 10. So you should write x of n minus minus 10 whole bracket close. So here this value is nothing but minus 10. So of course this value is nothing but minus 9, minus 8, minus 7, minus 6, minus 5 like this. So if it is 5, then it will be what, guys? It will be 6, it will be 7, it will be 8, it will be 9, it will be 10 like this. Everyone, guys, who reply fast, is this clear to you, beta? Both the question is crystal clear to you or not? Shall we go for next? Both the question is crystal clear to you or not? Shall we go for next? अच्छा बच्चों, हमने लिखा यहाँ टाइम रिवर्सल था, but we have discussed time shifting actually. So we should write here time shift only first, okay? After that time reversal we'll discuss, okay? So first operation, whatever we have discussed till now, that is time shifting actually. We have written time reversal. Time reversal we'll discuss just after time shifting. So first of all, tell me beta, time shifting is crystal clear? Now, sir, if question will come like this, then how to approach, sir? X of n, tell me bachcho, 1, 4, 3, 2, 1 or 3, okay. This is the question, and this time arrow is at 3. Arrow is at 3. Now can you please find x of n minus 4 and x of n plus 3? Bolo bachcho. Can you find this now? Just let me know where is the arrow. All of you guys, just let me know where is the arrow point and just complete this part. I am waiting. I am waiting, guys. I am waiting. So if I talk about the first question, guys, you just simply replace 0 with 4 in respect to the number. So 1, 4, 3, 2, 1, 3. Here earlier 3 as having the origin. This point is 4. So now the 4, this is 3, this is 2. If examiner can ask x2 value, so answer is nothing but 1, like this. X of n plus 3, it means again the number is same, sir. 1, 4, 3, 2, 1, 3, sir. 1, 4, 3, 2, 1, 3. And this 3 location is nothing but this time minus 3, sir. So if it is minus 3, guys, it is nothing but minus 4. It is nothing but minus 5. It is nothing but minus 3, so minus 2. Nothing but minus 1. And it is nothing but origin EX. So do it fast. Both the questions, you guys matched with this or not? Yes, 2 to 7. क्या बात है कृष्णा, क्या बात है वैदई. So its location is nothing but 2 to 7, sir. ये from 4 to 4, 5, 6, 7. So its location is 2 to 7, and its range is from minus 5 to 0. Yes, minus 5 to 0. Minus 5 to 0. Yes or no? Arrow at plus 4. Shabash. So first diagram is clear, beta. Second is also clear. Whether Purushottam, do reply. Second is also clear to you or not? Second is also clear to you or not? Hi, Anna. I think second is crystal clear to you. Chaliye. So now students, second operation we are discussing time reversal. Time shifting we have discussed already. Now it's time to discuss time reversal operation. So student, if I will discuss time reversal, let me take the graphical representation. So if this is my x of n curve, this is value 1, this is value 3, this is 2, this is 1. So it will be 0, 1, 2, 3, n. And this is my x of n, guys. Can you please make x of minus n? So of course, it is a time reversal operation is nothing but a mirror image or symmetrical with respect to y-axis. So you should make 1, 3, 2, 1. So it can be, sir, it can be 1, it can be again 3, it can be again 2, it can be again 1. So what you can say, 0, minus 1, minus 2, minus 3, and you can write like this, 1, 3, 2, 1. And it is nothing but time reversal having the mirror image, Bolo bachcho, hai na? Is this crystal clear? Shall we go for next? Pyare bachcho, do reply fast. Shall we go for next? Yes, do reply. So student, the same question if I will shift by using the sequence, then x of n is nothing but actually 1, 3, 2, 1, and here we have arrow. 1, 3, 2, 1, here we have arrow. Then what about x of minus n? What about x of minus n? How to write sequentially? So sequentially here is 0, 1, 2, 3. So x of minus n means reverse. It means right now I am writing from left to right, this direction 1, 3, 2, 1. In x of minus n, I will write right to left. And change the sequence 1, 3, 2, 1 like this. Now I am writing 1, then after this 3, then after 2, after 1. So right now, because of time reversal, we should write like this, and here is the arrow. Earlier arrow representing 0 here, now 0 is here. So it will be automatically minus 1, it will be minus 2, it will be minus 3. So this is nothing but your directly reversal operation. This is nothing but your direct reversal operation. Bolo hai na bachcho. So I think graphically will take more time sequential. If you will write the discrete time signal in sequence form, it always give you opportunity to save your time. Bolo hai na. Now suppose that here many students will confuse. Suppose that if action will come like this. 3, 1, 2, 4, 1, 3. And suppose that arrow we have had 2. So now how can you write x of minus n? This is very much typical in sequence, because many students directly go for the curve. They will write the graph. They will make the graph from this x of n, and after that they will perform the reversal operation. But what you can do smartly, what you can do smartly, directly reversal operation. Wherever is origin, that remains same too. Right now here you are writing left to right, and right now here you are traveling right to left. You have to just swap the direction. Instead of left to right, you should travel right to left, and instead of right to left, you should travel left to right. So here 2 1 3 is here now. Now it will be 1 3 here, and it will be 2 4 1 3 in this direction from left to right. Now you have to travel right to left, so it will be 2 4 1 3 only, and still arrow is at location same. So I hope this is clear to you, bachcho, how to directly perform reversal without making the graph, without making the curve. This is the smart approach, guys. The smart approach you will never find in textbook, reference book, bachcho. These all are the beauty of our classes. Shabash. Very good, beta. 3 1 4 2 1, arrow is at 2, sir. Shabash. Very nice. Very good, beta. Very good. Vedai. Shabash. Chali. So, pyare bachcho, that's all from today's class. Tomorrow we will meet at 12:15. Okay. So don't miss the session. Okay. I hope you already subscribe the channel, so you know that whenever we have a live session, you are getting the link also, and all the videos are also updated in the playlist also. Yes or no, bachcho? Chaliye. So those who are looking for the complete structure gate preparation for 24-25, you guys can visit our website imsindia.com/gate. Sir, कृष्णा और चारू के नाम से बुलाती है सर, बट ऑफिशियली मेरा नाम वैदे ही है. शाबाश. वेरी गुड बेटा, वेरी गुड. यस. सिमिलरली बच्चों, माय डॉटर हैज आल्सो सो मेनी नेम्स. सो जो मेरी बेटी है उसको भी ऑफिशियल नेम इज अनायरा शर्मा. बट घर पे हम सिया भी बोलते हैं, बहुत कुछ अलग अलग नाम से बोलते हैं, नन्ना भी बोलते हैं. चलिए. बच्चों, तो ऐसे ही छोटे छोटे बच्चों के प्यारे प्यारे नाम होते हैं. इसी तरह आप लोग हंसते रहें, मुस्कुराते रहें और पढ़ाई करते रहें. चलिए, बाय बाय बच्चों, टेक केयर. Those who are looking for the complete structure, once you will take the subscription, guys, you will get 800 plus live lecture access. You will get 26 to 30 hard copy of booklets. You will get 130 plus test series access. You will get 4,000 plus practice question, dedicated doubt solving portal, and one-to-one my plan mentorship session. Yes, सिया हम घर पे बुलाते हैं, घर का नाम है. चलिए बच्चों. So bye bye बच्चों, take care. That's all from today's class. We will meet tomorrow, bachcho. Welcome. You are most welcome. Bye bye. Bye bye.